And now, introducing Mr. Hillcock, an awesome algebra student from the southwest corner of the Spokane Valley. Today we'll be learning about inequalities. Now just sit back and enjoy the show.
All right, thank you, Devin, for that. Thank you, Devin, for that awesome introduction. Okay, so we will be learning about inequalities today, so let's go ahead and open up that document, and away we'll go. You have your practice test in front of you. So today we'll be going over each problem, and please, if you have any questions, raise your hand or get my attention so we can go over it and see what we can learn from the mistakes you made and clarify anything that you don't understand. So shortly here we will begin going over the test, practice test.
Tell us a little about yourself.
Well, that's okay. I don't know. I think people just want to learn math today, so let's get started.
I think
Okay.
want to learn math.
So, are you ready? Ready? Ready?
Yes.
Okay.
Let's get the show on the road.
Number one. Number one.
Negative boo.
When I plug in, okay, guys, this isn't going to go very well if you guys are interrupting me. Number one, if I plug in 8, I get, on number one, if I plug in 8, what do I get? Okay, well, Grace wants to plug in 2 first, so let's go ahead and do that. So we have 2 times 7 minus 2, or 2 times 5. Is 8 less than 2 times 5? Yep. How about 8? Is 8 less than 8 times 7 minus 8, or 8 times negative 1 is negative 8, so that is not. Is 8 less than 2 times, or excuse me, now we're doing negative 1, is 8 less than negative 1 times 7 minus a negative 1, which is plus positive, is 8 less than a negative number? No. And then if we plug in 0, we get 8 is less than 0, which is also not correct. So the answer is 8. Number 2, all we had to do was add fractions here, so we add 1/2 to both sides, but we know in order to add fractions we need a common denominator. So we have 3/6 and 2/6, which makes 5/6. So Q is greater than 5/6. On your quiz today, I'd like you to put a 0 if you can fit it in there, and then so I know that you know where this is, and 5/6 is just less than 1. Greater is to the right. Remember, if you put your variable to the left, it'll point in the direction to shade. Okay? All right, let's move on to number 3. Some of you can learn from this, but it might have been just a misunderstanding of what we were looking for here. So what is the important information? We want at least 325 cans. We have 135 the first week, 89 the second week. C is going to represent the cans of food to be collected by the end of the third week. And we want an inequality to represent how many we need to collect to meet our goal. So if we take the first week's cans, the second week's cans, the third week's cans, and we add them all up, and we want to have at least 325 cans. That was what I was looking for, so please on the test write something like that. Okay, you could also simplify this. A lot of you simplified it down to, that is 224, correct?
Yeah.
That's fine too if you took it one step further, but I wanted you to understand that was the inequality we were looking for. And I know it says how many cans are needed to meet or surpass your goal. I like the answer C is greater than or equal to 101 when you solve for C, but if you put 101, technically you answered the question. But it's really saying that 101 or more, and we say that with an inequality. Okay, number 4, we're going to multiply both sides by a negative. Remember, the only tricky thing in inequalities, or one of the tricky things, is if you multiply both sides by a negative, you reverse the inequality. That's the only thing you really have to remember on this one. And so x is greater than or equal to negative 8. And so I go to negative 8. If this is 0 here, negative 1, 2, 3, 4, 5, 6, 7, 8. And it's greater than or equal to, okay, it'd be solid because it's the equal to there. Number 5. We'd subtract 6, so we get 4x is less than negative 12, because that's plus a negative, divide by 4, and x is less than negative 3. So if we write that here, x is less than negative 3, since our variable's on the left, it points in the direction to shade, so we're going to shade left. So this is 0, negative 1, 2, negative 3, shade left. Okay? First 5, get you going. Hopefully you did really well on those. Those are meant to just kind of get your feet wet and to get some good points off the bat. It's an expression, figurative language. Okay, 8W plus 96 here. We're going to solve for W, so we'll subtract 8W and get 2W. 12 plus 2W is greater than or equal to 96. We're going to subtract 12 and get 2W is greater than or equal to 84. Divide both sides by 2 and get W is greater than or equal to 42. I think every single person got that right. Yeah. So W is greater than or equal to 42. This one, obviously, unless you did intervals of something other than 1, this one would be fine just to put your 42 wherever and just go ahead and shade. Okay. Number 7. This one is an and. Remember when we do an and, we want to go ahead and write 2 inequalities and solve them separately. So we have that, and then we have this. So we can go ahead and solve the top one by adding 4 and get 2 is less than or equal to 2x. So x is greater than or equal to 1 is one of my answers. X is greater than or equal to 1. And my other answer is 2x is less than 12, x is less than 6. Okay, so then I go ahead and get that out of the way so we can make this a little easier. So what is x? Well, x is between 1 and 6. So that graph is going to look like solid at 1. So if this is 0, solid at 1, 2, 3, 4, 5, 6, open there, and it's in between. Remember, the and is the intersection. Let me actually go ahead and graph those just so you guys are aware of that, how we got that answer. X is greater than or equal to 1 here. X is less than 6 here. And remember, when it's an and, we are looking for the intersection or where they're both graphed. Are they both graphed to the left? No. Are they both graphed at 1? Yes, that's why it's part of the final graph. Are they both graphed at between 1 and 6? Yes. So that's why it's part of the final graph. Are they both graphed at 6? No, that's why it's open circle. To the right? No, that's why it's not included. All right, number 8. Next page. Okay, number 8. We did not do number 8 because it's just like 7, so that was a skipper. We're going to skip that one. Number 9, we are going to go ahead and add 2 to both sides. So 2x is greater than negative 10. Divide by 2. X is greater than negative 5. Whoops, greater than negative 5. Or, when we subtract 3, 2x is less than 4, x is less than 2. So if we have negative 5, negative 4, 3, 2, 1, 0, 1, 2 on here, what do these graphs look like? Greater than negative 5, less than 2. Where is one or the other graph? Is one or the other graph to the left? Yes. At 5, this one is. At 2, this one is. To the right, this one is. So it's everything, or all real numbers. That's the solution. Okay? So the graph is everything, because if you combine the 2 graphs, everything is graphed on one or the other. You can't leave open circles there because those are part of the final graph. Okay? So that indicates that you jump over those, but they're really part of it too. So I think that's the one thing that caught a couple of you that were really close. Okay, here you subtract 3 from both sides. 2x minus 1 is less than or equal to negative 2x minus 1 divided by 3. We first want to get x alone, closer to being alone, right? So less than or equal to negative 7. You could have multiplied, you would have had to distribute that with that 3 also, so it could complicate things a little bit. So now I'm going to multiply by 3 and get 2x minus 1 is less than or equal to negative 21. Add 1, and 2x is less than or equal to negative 20. So x is less than or equal to negative 10. That is one of my answers. X is less than or equal to negative 10. And let's get rid of this right here. Okay, and then we have add 1. So we get 8x minus 2 over 2 is greater than or equal to 7. Multiply both sides by 2. And we get 8x minus 2 is greater than or equal to 14. Add 2. 8x is greater than or equal to 16. So x is greater than or equal to 2. Okay, so now we're going to go ahead and take a look at what those look like as far as our graphs. So x is this is a little funky. We can't write x in the middle here. Well, we can, but it would look weird. X is less than or equal to negative 10, and x is greater than or equal to 2. Well, let's look at those graphs. If this is negative 10, negative 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. If I just put a 2 out here, okay, that's 2. Let's take a look at what that looks like. Less than or equal to 10, negative 10, greater than 2, so that's going to be out here, and it's going to be shaded to the right. Where are they both shaded? Nowhere. No solution. Okay, you can leave it blank or go ahead and put no solution right on it.
How are they shaded nowhere?
Where's the difference? No solution.
Remember, and, when it's an and, you are looking for an intersection or where they're both shaded.
Oh.
Are they both shaded anywhere on either graph? Yes, Bo.
So I filled it out, but I also put no solution above it. So is that wrong?
Yeah, make sure you, I just make sure that your final graph, which are you guys doing at the bottom one is your final?
Yeah.
Yeah, just make sure that one's right. Because if you would lose points, because
Okay. Go
if
ahead.
you show one thing but write another, it contradicts itself, right?
Okay.
You know what I'm saying?
Yeah.
Okay, now this one, interval notation, this is just saying x is between negative 8 and 2, including 2. So that's what it would look like, okay? And how would you write that in interval notation? Remember I said that's because it's already there. So we're going to go ahead and my final graph, well, if I have negative 8 and I have 2, 0, so negative 8, 0, 2. So x is greater than negative 8, less than or equal to 2. Where are they both shaded? Between negative 8 and 2, not including negative 8.
I have a question.
Yes?
How do you know where to face the sign?
Yeah, I don't get it.
Okay, so if I write this out separately, I get negative 8 is less than x, right? And x is less than or equal to 2. Notice how the inequalities pointing to the left towards the 8 in both places here? That's right.
No, that's not what I'm saying. I'm saying how do you know from the bracket notation which way the inequality is going to face? Because x is the
Well, this x is the comma. So this is saying that x is between negative 8, not including negative 8, goes to 2, including 2.
No, yeah, I'm not.
x.
So x is
the
between
middle,
them. X is in between those two.
So the negative 2 number is always going to be greater than x. Is it?
Yes. Well, x is going to be greater than it. It's not greater than x. X is greater than the negative number. X is greater than negative 8.
Is that number 2? X is always going to be greater than the number.
No, x is less than 2 in this one, less than or equal to 2.
I mean, x is always going to be above. Or the number 2 is always going to be greater than the
Depends. What if it was 2 and 7? 2 comma 7. And x is less. Okay. Number 12. How about this one? X is less than 8, or x is greater than 10, right?
Yeah.
So
So,
x 0?
so x is less than 8, so it's going from 8 to negative infinity. What does that look like on a graph? If this is 0, this is 8, this is 10, right? 0, 8, and 10. If x is less than 8, it goes there. So it goes from negative infinity, remember, to 8. Okay? Or it goes from 10 to infinity. So 10 to infinity, okay, this is what infinity is, so it's going from 10 to infinity. Positive infinity. So then it's an or, so we have to combine the two. So where are they both graphed? Everything to the left of 8 and everything to the right of 10, not including either one. Okay? Not too bad, right? Ors and ands. Now graphing linear inequalities. Oh, we have 35 minutes. We're good. Okay. Okay, well, we'll see. All right, so this one just gives me the y-intercept, right? Negative 5. Gives me the slope 3. So I'm going to rise 3, run 1, rise 3, run 1. Is it dashed or solid?
Yeah.
Dash, good. You guys got that. It's a dashed line. And then lastly, someone came up and said you need to shade it. And I said, well, what do you think? It's an inequality. Is the solution the line? Well, no, especially not if it's dashed. If it is solid, it is the line. But with an inequality, remember, it's different because it's a bunch of solutions either side of the line, an infinite number of solutions. So I always like to plug in 0, 0 if possible, and I can on this one because it does not go through 0, 0. So when I plug that in, is 0 less than 0 minus 5, or is 0 less than negative 5? The answer is no. So since that's not a solution, nothing over here is a solution. Nothing, okay? Everything on the other side is the solution, so that's why we're going to shade over here. Right? And you just have to shade coordinate plane. It implies that everything's going to be shaded. Is that a question, Brendan? You're just stretching? Okay. This one, the only tricky part here was to get y alone. So subtract 4x. So I have 6y is greater than or equal to negative 4x plus 10, and then I divide both sides by 6. Don't forget to loop it. So I get y is greater than or equal to negative 2/3 x plus 10. Someone, I recall reducing that wrong. 10/6 is 5/3 or 1 2/3. Okay. The reason I want that as a mixed number is it's easier to graph that y-intercept. If I think mixed numbers when I graph y-intercepts or any point. So 1 2/3, I'm going to go down 1, 2, and over 3. Okay, dashed or solid. That one's going to be solid, right? So I'm going to go something like that. Adjust it a little bit. And then I need to shade appropriately. Graph a little bit. And does 0, 0 work? Is 0 plus 0 greater than or equal to 10? Is 0 greater than or equal to 10? No. So since 0, 0 does not work, we're going to shade to the opposite side of that over in here. Okay? All right. Now, systems of linear inequalities are the same thing, except for we're looking for the intersection of the shaded regions. That's all. The only difference. Okay? First one, not too bad. Graph the y-intercept of 4. We're going to rise 1, run 1, rise 1, run 1. I'd like you to do one at a time. The reason I want you to do one at a time is so you don't get confused with what you're plugging in and what side to shade. So let's shade this one. 0, 0 is right here. Is 0 less than or equal to 0 plus 4? Yes, it is. So I'm going to shade to that side for this one. So I'm going to get my biggest possible shading there. Okay, so I'm going to shade all that in. I'll just stick to the coordinate plane, but of course it's everywhere to the right and down kind of area. And then, whoop, don't want to shade that part. And then we have, I guess we'll have to take that out and fill it back in. Okay, and then we have the other one, and that is going to be a solid line as well. So it's going to be solid as well. We have to get y alone by subtracting 2x, but that's all. So we have y is less than or equal to negative 2x minus 4. Where are we going to start? Negative 4. 1, 2, 3, 4. We're going to rise negative 2, run 1, or rise positive 2, run negative 1. It is a solid line, as we said already. And now we just have to figure out which way to shade. So it's going to be like that, and then does 0, 0 work on this one? Is 0 plus 0 less than or equal to negative 4? No. So since that doesn't work, I'm going to shade this way, right? Okay, since 0, 0 does not work. And so we're going to go ahead and shade that. We'll do the cool color thing here because yellow and green make blue.
What does it? Green.
Yeah, that didn't work as well this time, did it? Okay, but that's the answer.
Well, you have to check above it too.
Right. Well, no, because up here.
Yeah.
But that's not part of it, and because our colors aren't standing out as well as they normally do for some reason, we'll take that. All right. Next one. Y-intercepts negative 1. We're going to rise 1, run negative 1. And what is the, is it solid? Yep. Does 0, 0 work? Is 0 less than or equal to negative 1? No. So I shade down below, right? Shade down below.
I haven't missed any more.
Okay, shade down below.
How can your things be all wonky?
I don't know. Wonky, that's a great word, though.
Is that sarcasm?
No, that explains it very well. Actually, a very descriptive word in that situation. Good job. Okay.
I tried to.
1, 2, 3, 4.
Yeah, I think I understand it.
Okay, wonky's kind of become a popular word the last few years. So, I know why, because we're supposed to do blue and yellow. All right, can't shade yet, right?
Right.
Okay, first we need to put in the line into this solid.
Don't get ahead of yourself.
I know, right?
You should use purple. No, use blue.
Well, considering the time it would take to switch, Brandon, I think we're better served to
Will that be a nightmare?
do it right now. All right, 0, 0, does that work? Is 0 greater than or equal to 4? No, so I'm going to shade below. Or I'm going to shade up here, right? Okay, so let's go ahead and do that. And where is the intersection then? There we go. There we get the blue and yellow make green, so you can see that the answer is everything over in this region here. Okay? This is not shaded on one but not the other up here. Okay. And almost there. And you're going to have probably a good 20 minutes to get started on your test.
Oh,
So,
yeah, I want to.
these ones are good questions. You're just working the opposite direction, making sure you understand the shading, the writing of the equations. So I'm going to pick one at a time. I'll pick this one first. I'll pick this line first. Okay, what's the y-intercept? -6. So it's going to be -6. What's my slope? 1, 2, 3, -1. 1, 2, 3, -1. Do that a couple times just to make sure. So my slope is -3. So now I just have to guess. Do I think it's going to be less or greater?
Well, it has to be less.
Okay, well, let's find out.
No,
So,
like, it has to be below 0.
well, I know, but let's just double check. All right, so now we're going to say, I think it's less. What if I put in 0, 0?
Or equal to.
If I put in, thank you. Or if I put in 0, 0, does it work? Is 0 less than or equal to -6? No. So it is correct. Y is less than or equal to -3x minus 6. Any questions on that? Everybody follow that? Yeah. Brandon, you got that?
Yeah.
Okay, because that's not easy. Okay, good. Just make sure. Just opportunity to learn for some of you who are like a little confused on that one. So this one, this y-intercept is -2. So I'm going to subtract 2, right? What is the slope? It is rise 1. It looks like over 1, up 1, over 1, up 1, over 1, up 1. So it's just 1x. And then is it going to be less or greater? I'm going to try less than or equal to. Is 0 less than or equal to -2? No. So it shade the opposite direction. So that is right.
That will be one nightmare.
Okay? If you had one of them right, you get half. Well, if you had this right but not the shading, you get half. Yes, right? No. Okay, Ryan had a good question, guys. Can these be in either order? Yeah. You just want the 2 inequalities. Doesn't matter what order.
I feel really stupid right now. I feel y is less than or equal to 2 over 2x minus 2.
Okay. This one here, let's look at this one. It has a y-intercept of 8. So let's go ahead and do that. Y-intercept of 8. Okay, what's the slope of this? Well, it looks like it's 1, but let's find out. Yep, 1x. That was tough.
I put 2 over 2x again.
Okay, 2 over 2 reduces to 1, right?
So that's right.
Okay, we reduce. We always reduce.
But is it right?
Reduce.
Would you knock me points?
Probably yes. At this point, you shouldn't be doing that, right? Okay. It looks like it's less than or equal to, but I'll check it. Is 0 less than or equal to 8? Yes. And it's over here, so it works. Please pay attention. Those of you who aren't paying attention, be really sad if you miss some of these problems we're going over right now. And -8, rise 2, run. This is what I want you to be careful of. It looks like you can rise 2 and go -1, but that's not it. It's rise 3 and run -1. Rise 3 and run -1. So do it a few times just to make sure that you have your slope right. So it's -3x, and that is -8.
That's so wrong. You told me it was -2.
Okay, and then we're going to the 0, 0. It looks like it's going to be greater than or equal. So if I put in 0, 0, it should work. Is 0 greater than or equal to -8? Yes. So that is the answer. Those are the answers. So we have y is, let's just do this.
1.5.
Well, that means you are going to do really well in the actual test. Cool, probably.
I looked at the hat for not saying or more on one can. And I didn't, and I put the less.
We don't have to do this, but we can start.
Oh, we need to do the bonus because some of you might need this. Okay. So if x, so hang with me guys for about 3 more minutes and then you can start your test. If x equals the length of the garden, and y equals the width. What do I know about this? The garden should be at least 110 feet, the length. So x has to be greater than or equal to 110. Right? Okay? That's why defining the variables is key. If you don't do that, there's no way you can even start this problem. Okay? And then, what do I know about the perimeter? Well, I know the perimeter of a rectangle is always 2x plus 2y. And it can be no more than, so it has to be less than or equal to 380. So then, if I look at my x and y intercepts, well, I know this, the x has to go up to 110, and this is 19 spaces. So if everyone's 10, so this would be 20, 40, 60, 80, 100, 120, 140, and so on. Okay? And so x has to go up there, right? Because x is greater than or equal to 110 is going to be a vertical line. Actually, it's going to be an array. Why is it an array?
Because he has to go negative.
Because it can't go negative, right? It can't have a negative length. So it would be an array at 110. So we're going to go ahead and put that there. Okay? So, and then it's greater than or equal to, right? So where's that going to be shaded?
To the right.
To the right. To the right. Okay?
That was good harmonization.
That was. There you go.
We should make a band.
Make a mixtape.
He's already part of the band.
Okay. And then, what are my x and y intercepts here? My x-intercept is, when I cover that, you guys can't see that, but when I cover that, x-intercept is 190, right? When y is 0. And my y-intercept is going to be the same, isn't it? So isn't that a really easy way to graph this one? I think so. This is 190, and this is 190, because I know there's 19 spaces from here to here, and each one's 10. So this one would be really easy to graph like this. This would be a complete segment, because you can't have negative of either. So this is going to be a segment, line segment, so something like this. Okay? And then where would we shade on that one? Well, it needs to be less than or equal to. So our answer is going to be this little region down here, which is there. Because it's 0 less than or equal to 380, yes. So we'd shade to the left, but the part that is an intersection is this area in here. That's it. Of course, we'd label these, right? This is length, width, and we're talking about our community garden. Boy, she title. So that wasn't so bad, right? I expect good scores, have confidence, do what we've been learning, utilize your toolkit appropriately, check your work on your calculator, and I expect very good scores.
Keep up to make sure, guys.
Yep, just want to make sure you heard that. All right.